You're listening to the Autism Weekly podcast. Each week we share community voices and bring light to stories that increase awareness, acceptance, equity, access, and inclusion. If you haven't already, subscribe to join the Autism Weekly family. I'm your host, Jeff Skibitsky. This week, we're joined by Dr. Rosa Krajmalnik-Brown, a pioneering researcher at Arizona State University, whose work is changing how we understand the connection between the gut health and autism. Dr. Krajmalnik-Brown and her team were the first to show that changing the gut microbiome can actually change behavior and improve autism-related symptoms. This is a conversation for every family, every caregiver, and anyone who has ever wondered if what's happening in the gut might be connected to what's happening in the brain. Welcome to the podcast, Dr. Rosa Krajmalnik-Brown.
Thank you for having me here. Thank you for the invitation. It's a pleasure.
Oh, it's a pleasure for me. I love learning about the research that is out there that might be even new for me to digest. And I've been in the field for a while. So I think for a lot of families out there, this is going to be very interesting and it might put some behaviors into perspective. So let's get started. And you have an interesting background because a lot of people that fall into autism research or are looking at being within the service industry for autism, they are not coming from the engineering world. So tell me about that path of how you went from environmental engineering to ending up researching autism in the gut.
All right. So I think my path is fascinating. I always wanted to do something to help people, and that's why I went into environmental engineering. I wanted to help a lot of people. I wanted to help the world. But also, I always was fascinated with microbes, and I always work with microbes, with bacteria. And in environmental engineering, I used to work, or I still do some work with microbes and bacteria that can clean water, can produce energy. But a key feature of my research in environmental engineering is understanding how microbes interact with each other and with their environment. And so we do a lot of this using genomic-based techniques, DNA. So what we do is we get a sample, soil, water, whatever the sample is, we extract DNA, and we get the genomic signatures of these microbes, and that's how we understand who is there, what's changing, how they interact with, and we measure chemicals also. So I have been doing this for a few years. When I came to ASU, I was privileged and blessed to come to ASU to do a postdoc with Dr. Bruce Rittman, who is a person that is very, very famous in environmental biotechnology, basically a Nobel Prize winner. And he had a lot of stuff going on, but he needed someone who would help him analyze microbial communities in his reactors. That was me. I did a postdoc with him. And during my postdoc, a gastroenterologist at the Mayo Clinic, Dr. John DeBase, wanted to start working on the gut microbiome. This was right before the Human Microbiome Project launched, so the timing was great for me. And so John DeBase was scoping the area in Arizona who could help him with the tools and methods to analyze microbial communities. And someone told him, hey, Bruce Rittman in his center does this for reactors. So Bruce said, yeah, we have the methods. We was mainly me, but yes, we had the methods. He set up a meeting, we met, we wrote a small proposal that was a Mayo ASU proposal, and we got a small project to analyze gut microbial communities and how gastric bypass changes microbial communities. Here I got super lucky because normally when you run a trial or you do comparisons with the microbiome, you need tens or hundreds of people to get statistically significant results. But gastric bypass changes the community so much that with a triplicate, with 3 patients, we were able to get statistical significance. So I started my journey into the gut microbiome with metabolism and with bariatric surgery. And at the same time, Dr. Jim Adams, who is my collaborator in autism, has been for many years convinced that there's a component of the microbiome with autism. And he wanted to answer this question also. And he had a student, a PhD student, that was actually borrowing a bench from Bruce Rittman's lab, which is where I was doing my postdoc. I remember talking to her. And she was trying to isolate microbes. She was trying to isolate microbes from samples to provide proof that there was a difference, and just in the gut microbiome of kids with autism and typically developing kids. And I remember telling her, hey, Linda, that's not the way to answer that question. I can help you. We can get DNA and we can do this. Long story short, eventually Linda left, and I approached Dr. Adams and told him, we have the methods. I show him what we had done for bariatric surgery, and I have a postdoc that could work on this. And we started. He was convinced. He actually posed the question, but I had the methods to try to answer the question in a better and maybe different way.
That's amazing that you were able to kind of work through that entire process, because you're taking two different sciences to solve a very complex question.
Let me tell you another little part. Like, he said he was convinced that there was a difference. And I said, okay, let's get DNA and let's use the methods that I've been using to ask that question. But another important component of my research is that I've always thought about microbes as my friends. If you come to my office, you will see there's a sticker that says, microbes are my friends. Microbes will clean water, microbes will make energy, microbes make you healthier, And so when we came into this question, we came with different glasses. We came with the glasses of like, are these kids maybe missing beneficial microbes? Which is actually what we found in our very first study. In our very first study, where we had only 20 kids that were typically developing and 20 kids that were in the spectrum, one of the things that we found is that they had a microbiome that was less diverse, less different types of microbes, and that they were missing beneficial microbes. And so people had been looking at this question with a different angle also, like, are they bad microbes there? We were looking at it with the tools that I had, which were advanced tools, and B, with a different angle. So it's been a journey. It's been fascinating. And I do remember when I was an assistant professor working with bariatric surgery and obesity and metabolism, one time I went to have lunch with Bruce, with my postdoc advisor, who is still my collaborator and amazing mentor. We're still working together. And I told him, I know that there's a lot to do in metabolism and obesity, but I feel that this is a place where I can actually make a difference on autism and the microbiome. I said, I know this is the place that not so many people have looked at it to begin with, and I feel very strongly that this is where I can make a difference. And it looks like I was right.
Well, and I think that learning from the research and then creating just different pathways for treatment is, that's where you're taking the practicality of that science. But before we go down that road, how do you explain, I guess, for those of us that maybe aren't in the biological sphere, a gut microbiome? A, what is a gut microbiome? But B, what is it that we're seeing from an autistic child that maybe either has the deficiency of not having the right microbiomes, their gut microbiomes, or has maybe the wrong combination or something that's interacting? How do they present differently?
Okay, so the gut microbiome, as the definition, is the microbes that live in your intestines. And microbes are bacteria, archaea, fungi, and viruses. It's a lot of things. A lot of people, when they talk about the gut microbiome, mainly focus on bacteria. Our team has also been looking at fungi, but which is yeast, for example, candida, which is important. And we, in our first microbial transplant therapy project, we also looked at phages, which are viruses that interact with bacteria. Archaea, we've looked at archaea also for other microbiome projects, but nothing has jumped for us with archaea with autism. So that's why we haven't looked at it, because it hasn't jumped as an important player yet. But we have the methods because we've looked at that for other diet studies. So that's number one. Who is the microbiome? Bacteria, archaea, fungi, viruses. And most of what I'm going to tell you today is about bacteria, just to be clear. But yes, like I said, we've done work with other parts of these microbial kingdoms. They're very important for us because the bacteria that live in our gut do amazing things for us. They're our partners, like I mentioned before. they help us digest the food that we eat. That's action number one that has been known for hundreds of years, that you have bacteria in your intestines that help digest your food. When they help digest our food, they produce vitamins, they feed our colonocytes, they produce chemicals that are good for us. They also might produce chemicals that are not so good for us, which is part of the problem. And so when I say they produce chemicals that are good for us, you probably have heard serotonin. Serotonin is the chemical that makes us happy. The tryptophan, which is the precursor of serotonin, a lot of the serotonin is produced in the gut. And microbes are involved in some of the production of this, serotonin or other chemicals. Dopamine. Dopamine is another neurotransmitter that microbes can either help the production or diverge the pieces of the puzzle that would make dopamine, they would divert it to do other things which are not so good. So these are some of the things that we're learning about when we talk about the gut-brain interaction. And so, yeah, that's super important. Simple terms, which is what brought me into getting interested in autism. One of the things that my collaborator, Jim Adams, educated me with when we started working together was that many individuals and kids in the spectrum have a lot of gastrointestinal symptoms. And so some of those gastrointestinal symptoms include constipation and diarrhea. Constipation and diarrhea will change the amount of time that a microbe spends in your intestines. It will change the balance because it will change who can survive and who stays and who goes. And so it changes the dynamics. And that's very important because depending on those dynamics are the chemicals that are coming out of our gut. Are they good metabolites like butyric acid that feeds our colonocytes, or are metabolites that are actually diverging the flow to produce good things?
So what is I mean, you explained the effect that it might have on some of the neurotransmitters. I mean, you're talking about serotonin, you're talking about dopamine, you're talking about digestion, you're talking about, I mean, there could be some severe agitation. You could have somebody who's not engaged. You could have somebody that doesn't have attention, doesn't have energy. Are all of these the behaviors that might be more presented, more objective to be able to see and observe from a child who may be having some challenges within their gut?
Yep. Yeah. So in summary, what I always tell people is that, like I said, microbes are your friends, they're your partners, and it's a partnership. So a good partnership makes you happy. It's like a spouse, right? A good partnership makes you really happy. And a bad partnership is horrible. You'll be miserable. So in a way, we need to really embrace this partnership and make our microbes happy so that they can make us happy too.
Absolutely. And I always look at whenever you're doing any sort of treatment, any sort of support for somebody who identifies autistic, is that you're always looking medical first. You're looking to see, is there something that I could be doing that helps support this person from a medical viewpoint. But then I'm thinking, okay, so you just explained to me that how much the gut actually is affecting so many other components of somebody's body, the way they function, the way they think, the way they're feeling the world around them. So as we start thinking through that, is how did you take your research, or how are folks taking your research in actually translating that to practical intervention or supports?
So we are actually doing practical interventions, but we are right now on clinical trials. So on our first study, we learned that these children were missing beneficial microbes and that they had less diversity, less different types of microbes, which is really important for a healthy gut. So what we did is we devised this intervention that we call microbiota transplant therapy. And what this microbiota transplant therapy is a combination of first treatment with antibiotic to get rid of the microbes that are there, a bowel cleanse, and then we provided 8 weeks of microbiota from a healthy individual.
Mm-hmm.
And so we did this initially on an open label study. Open label means that everyone is treated and everyone knows that they're being treated. We had 18 kids that were being treated. And the results from this open label study were pretty amazing. I would say this is one of the things that put my name in the map of like, she's doing great things in autism and the microbiome. I was already in other maps, but this is actually what captured a lot of attention for the world, not just for the United States. Because with this trial, we actually observe on evaluations that were done by an external. Well, first of all, we proved that we changed the microbiome. That's with our methods, with DNA methods, we proved that we changed the microbiome. So we did what we wanted. We increased diversity, and there were a few beneficial microbes that we were tracking. One of them is Prevotella, which we found was deficient in the first study. Another one, Bifidobacterium. Bifidobacterium is part of many probiotics. And so we increased them. We increased beneficial microbes. We increased diversity. And we also show that these children, their GI symptoms improved dramatically. At the end of the treatment, they were 80% better. Some of these benefits got lost later because we did a 2-year follow-up, and we know that everyone was better than in the beginning, but the 80% wasn't as amazing as it was. But they improved a lot on CARS evaluation. CARS is Child Autism Rating Scale.
Mm-hmm.
And I normally like to talk about this evaluation and not others that we did, which we did many others, because this evaluation was done by an external evaluator. And that's important because we know that this was an open label study. So there's a placebo. There's a placebo
Mm-hmm.
component here. So it's important that it was done by someone external. We saw 45% decreases in ASD symptoms with the CARS evaluation. When we started the study, we had 83% of the participants were rated as severe based on the CARS scale. And at the end of the study, on our two-year follow-up, which they improved even more by the follow-up, we had only 17% were severe, 39% were mid to moderate, and we had 44 that were below the cutoff for ASD. So I have a graph that I usually show that shows like these 44% that were below the cutoff. Mm-hmm. And these little 44% were below the cutoff got the media crazy. Like everyone was so excited about these results. The Economist wrote about our work. We got fast track for FDA for our next studies, which is great. And I know that you like more personal anecdotes, so I can tell you too that I still remember, even though this was many years ago. I don't interact with the children. My collaborator and I designed the studies together. Mm-hmm. His study coordinators interact with the children, and we have someone who makes the evaluations. I get the biosamples in my lab. So I see the microbes, I see the chemicals. I don't see the children. I don't see the children unless they are on podcast or they are interviewed by the media, which I've seen a couple of children because they got interviewed by the media. But I get messages many times from the study coordinators. And I remember one message from a study coordinator that mentioned that one of these children was not doing well in school. And the teacher had told the parents that this child was not going to move on to the next grade. The child came into our treatment, and after the treatment, the teacher called the parents and said, "We need to talk." And so she said, "I don't know what you did with your child, but your child now is socializing, is talking with other kids, is paying attention in class. He's fine. He's going to move to the next grade." This is pretty amazing.
It is.
There's another child that was on the news. The ABC News in Phoenix made like a little thingy, and they interviewed his mom and they interviewed him. And the mom said that the child started the study, and within a few days she could see a change. He was sleeping, which this goes back to some of the melatonin is also produced in the gut. He was sleeping. He wasn't wetting his bed. He was doing better in school. And they interviewed the child. Oh, and they were able to move him from a special school to a normal class after the treatment. And he's talking nicely to the reporter. And what touched me the most is that at the end of the interview, the reporter asked him, what does he want to do when he grows up? And he says he wants to be a doctor because he wants to take care of people. So
That's
that was
amazing.
pretty amazing. I was
Uh,
like, I was so like, this is great that what we're doing is changing lives. So we are aware, though, that our first study was open label and there is some placebo effect. So we're running right now phase 2 clinical trials where we have a placebo arm and we have, it's blinded.
yeah.
So
Well,
we are aware of that, but we changed a few lives. I had someone
absolutely.
who interviewed me soon after this phase 1 trial, and he said, yeah, I know that a lot of people say that this could be a placebo effect, but if you could just replicate it, even if it's a placebo effect, your effects were so dramatic and so huge.
Hmm.
So we're pretty happy that we changed some lives, and we're trying to advance this forward and learn as much as we can to hopefully make it wider to the ASD population.
Well, I
And
mean,
so you
even
ask what you continue,
I was going
sorry.
to say is that even with those two stories alone are pretty amazing stories, but even for those that had moderate effects or where it helped them to support, is that now you're talking the potential of
Hmm.
somebody that is sleeping better, somebody that's cognitive ability has improved, somebody who potentially is less agitated or
Exactly.
is feeling more comfortable within themselves. Each step of that allows somebody to access learning, access other treatment modalities because your body, your mind is in a better condition. So the foundation of doing something where you're looking at how can I help support the entirety of a child, which might start with the gut. It might start, depending on where your doctor is telling you, in a variety of different places. It's the holistic approach of looking at all these components and how they can help support one another. Is this something where, I mean, you talked about, a procedure. I mean, your ultimately is that you were doing the flushing, you were replacing a lot of the microbiomes. Is that something that is needed for everybody? Is it something that the doctor would be helping to kind of identify, this is something that I would say would be potentially useful for you? Whereas maybe there's even some dietary supplements somebody else might be saying is that the way your body's processing something, this might be more supportive for you. How would you approach, the idea of more intrusive versus less intrusive treatment for something like this?
Yeah, so you asked more intrusive versus less intrusive, and I've been asked, and I think you were probably going to ask, so I'm just going to bring it up. What are potential interventions to change the gut microbiome? And when people ask me about that, I usually list them into what's easiest, right? So what's easiest is diet. Easiest because you don't need medical permission, but it's actually harder because it's very difficult to stick to it. So it's
Mm,
easy because anyone can do it, but it's not easy to adhere to it. Even us adults, we know what we're supposed to be eating, and how many times do we eat things that we don't know it's the best for us, right?
hmm. Yeah.
Adhering to a diet is challenging, but it's the easiest one because you don't even need any approval for that. You don't need, yeah. So I would say diet is the one that I say usually is number one, and diet does make a difference.
Hmm.
However, one of the challenges of diet is that it's very difficult to stick to it. And so we all know that, that's not news for you or for me or for anyone who listens to this. The second one is probiotics. And the challenge with probiotics is that most of the probiotics that you can purchase on the store are microbes that their natural environment is milk, not the human gut. That's number one. And number two, most of them, or usually these probiotics, don't stick. And so they come and go. Do they have beneficial effects? They do. While they're there, they change a little bit the community, they change the environment. They're like, I take probiotics every morning. But that's the
Hmm.
key. You have to take them every day because they don't stick. The other thing that you can do to change the microbiome are prebiotics, which are things that will feed the microbes. And that's kind of its appeal. Also, it's like probiotics, you can take it. So that's kind of easy to implement. But the challenge with prebiotics is that it's not so greatly understood which types of microbes they will change. And if you don't have the right microbes, they might also come in and change the bad microbes. The next level is symbiotics, which is a combination of probiotics and prebiotics, which the way I explain this is you're sending the microbes with their lunch. So it's, in my opinion, if you have a more targeted approach, this is better, in my opinion, than probiotics if you know what you're doing. Because like I said, you're sending the microbes, but you're also giving them some ammunition so they can go in and, do what they need to do and fight the other microbes if they need to. And so the next level is antibiotics. And I'm putting it at the next level because in order to do antibiotics, you would need a prescription. You need a doctor to tell you need antibiotics. And the challenge with antibiotics is that most of the antibiotics on the market will get rid of the bad microbes, but also will get rid of some of the good microbes too.
Mm-hmm.
We don't have antibiotics that are specific that will just go for the evil guys. They will deplete. I remember growing up, my mom, who wasn't a microbiologist, every time we had antibiotics, she would give us probiotics after antibiotics because she somehow knew, just like mom to mom knowledge, that you're depleting she used to call it the gut flora.
Mm-hmm.
You're depleting the gut flora with antibiotics, so you need to reseed it. So she would always give us probiotics after antibiotics. The other one is antifungals, which I know that it's used widely on the autism community because there's fungi like Candida that also takes over. And the most, I would say, intensive one, but we've seen the best results with it, is what we do, which is the microbiota transplant therapy, which is like spin-off of what they call an FMT, fecal microbiota transplant, which is like, it's a community that has more than 500 different types of microbes. That's one of the advantages compared to a probiotic, which has maybe 10, 12 strains.
Yeah.
And these are microbes that their normal environment was the gut. So you're trying to put them in and just go kind of either fight or interact and maybe befriend other microbes. But it's easier for them to succeed because that was their natural environment, not like a microbe that came from milk.
Yeah.
From other.
Almost like you're restarting an entire community down there where you're starting fresh and you can kind of grow it the way that you need to. So, I mean, it makes sense, but it sounds like each step of these decisions requires a specialist, requires a consultant, because I would imagine that my body is processing things far different than your body, far different than somebody else's body, and that what we might be at deficit of, or what we might have excess, or might have the wrong microbiomes for, completely different. And not doing it with a specialist could potentially cause as much harm as good. Is that safe to say?
I agree, but I agree. And I've mentioned many times, I'm not a doctor, so I never provide advice. I do know that each person also has a different microbiome. We have different metabolism, we have a different genome, and also like in our bodies, we have 100 times more genes from microbes than from our own genome. So I usually say we're 99% microbe, and that 99% microbe of us is different in every person. So you can't provide the same intervention. Or MTT has been pretty good for most of the people, but this is one of the things that looking forward we would like to improve is, can we find people that are better responders and people that would not even be responders? Can we find either microbes or chemicals, which we have some candidates, by the way, that would allow us to say, hey, you're a great candidate, let's do the treatment. Or, you know what, you're not a great candidate, don't waste your time, don't waste your money, And it would be good, it would be great if our knowledge is advanced enough that physicians can also use this knowledge, for them.
Well, the idea of precision medicine, I mean, it's built around that same premise of if we can understand somebody's makeup and how they're going to respond, then we can tailor all of this so much better. But in the meantime, doing these consultations, getting somebody who really understands that science to be able to help guide you on that journey, to be able to kind of better prepare your body, I think it's always wise. But similar to everything else, as research is moving into the general community and you're starting to see the intervention possibility, you're always going to have detractors or people that don't understand the science yet. When you're talking with physicians, because they're a big part of this, what are their what are their misconceptions? What are their concerns? I would imagine some are valid, some are just, I don't know. I've never understood this. It's not something that I studied historically. So, I mean, but how do they respond typically, the
I think
physicians?
most of the physicians that I talk to are pretty excited about what we're doing. Like, I have not encountered a physician that is skeptical about what we're doing. Most of the physicians, or all of them that I've talked to, are like really excited and really like they understand that, some of us call the gut the second brain, it's like a different organ and a second brain. And they understand that it's really important. And if nothing else, they understand like my motivation. I think I went on a tangent, but my first motivation for this was the GI symptoms. And my first motivation was like, if we can just relieve the GI symptoms and make these kids feel better, they'll have better quality of life.
Mm-hmm.
Like that was the beginning. Like, honestly, I did not know about the gut brain connection. I did not know about these amazing chemicals that are being formed in the gut. I learned about that later. My first, idea was like, let's help these children. If we can help just with the GI symptoms, that will give them a better life quality. We've
Mm-hmm.
gone above and beyond that, which is amazing. We proved actually with our first study that what happens in the gut doesn't stay in the gut. We measure chemicals in the blood, in plasma, and we were able to see shifts just with the treatment, which is amazing.
Mm-hmm.
So we know that, and we have evidence of that. So I've never had skeptical physicians. There's been a little bit of skepticism in the field, and I will mention there's been two papers that basically detracted the impact that we think we see on the microbiome. One of them said that the effects that we see and the changes and the differences that we see in the microbiome are mainly because of diets, because these children have very different diets. And I had a reporter reach out to me when this paper came out, and I said to this reporter, yes, maybe some of the differences of the microbiome that we see in these children could be because of the diet, but that does not detract at all from the fact that we showed that when you change the microbiome, you can change those GI symptoms and you
Mm-hmm.
can change, the ASD related symptoms
Yeah.
regardless. So that was one paper. And regardless, maybe yes, it is restrictive because of diet, but once you change the microbiome and you increase the diversity, there's a possibility that these children now are more adventurous with what they eat, and
Mm-hmm.
now they have a better diet and now they have more diversity. And now you just change the equation.
Yeah.
And there was another paper that said that it's mainly about human genetics and that the whatever we're doing with the human microbiome also, it's not exactly important. Let's just put it that way. And my answer was the same. We've proven that when you change them, I've never claimed that we have the cause of autism or the microbiome is the cause of autism. I've never claimed that, and I'm not claiming it. I've also never claimed that we can heal and cure autism. I would never claim that either. We can help with symptoms, which would help this neurodivergent population be the best they can be and be
Absolutely.
better with their family and with their parents,
Mm-hmm.
which is really different to making any of those two statements. And that's why I'm not afraid to say it, and I'm not afraid to say we change the microbiome. We're the first ones that show that you can change the microbiome with people, not with mice. Because a lot of people have done with mice, which was also one of the criticism of this paper that said, like, what is an autistic mice? Which there's a whole other story about that. And I'm like, we don't work with mice. We're not healing mice.
Mm-hmm.
We're working with people and we're making a difference with people. And I think that's what matters.
Yeah, even if you can remove some symptoms or make some barriers go away to be able to help somebody to empower themselves easier or to be able to contribute in the way that they want to
Yep.
with less of a restriction. I think that that's amazing. I always laugh at science and the fact that like you started with the idea of, hey, you know what? I really want to look at the GI symptomology and the agitation, discomfort. You're able to get to the fact that, hey, there's a huge connection here between that and somebody's neurologic experience and how they're able to kind of function and kind of the neuroscience of it all. Where are you hoping that your research goes next? I mean, it sounds like you're trying to figure out a little bit more on how to be able to tailor it better to the populations that you're trying to be able to help support. But what's your next goal? I mean, it sounds like you're moving this along nicely.
Yeah. So, okay, let me mention two things and you let me know later if we need to cut that. But we have two companies. So we created a company, Gut Brain Access Therapeutics, which we're using this company to help us get funding to move clinical trials, because at the end of the day, we want to have something that is available for all families. So we would like to have FDA approval for MTT. So that's Gut Brain Access Therapeutics, GBAT, gbat.com. And then also you asked me about how do we know what's differences? We have another company that it's autism diagnostics, and G, my collaborator, also just has an autism lab, diagnostics lab. He's been working with a lab in England, which is Analudos, looking at some of these chemicals that I mentioned that we have kind of on our radar. So he has a test that you can do urine. It's like one of the easiest ways to do this test. And then measure some of these chemicals that we've been tracking, because they're microbially derived, but they're not so good for you. And that might be like diverting pathways that are important. So this is important for families to know, because if they're interested in doing this test, that's Analudos or the autism diagnostics. That's something that hopefully we'll have a test in hand like in a week or two here in Phoenix, which is great. That's as far as application, but as far as research, I'm really interested in which are the important microbes. I don't think it's one, I think it's a team. Which are precisely the important chemicals, and can we use this knowledge, to get a better formulation or something that we could even grow in the lab? Or can we also do this to, like I mentioned, having better responders, like a way to say, hey, you're going to be good with the test, or this is not going to work for you. So let's go to your doctor and try something else, because this is not going to work for you. Or you're an amazing applicant. This will work because you have the features that we're trying to heal, the features that we're trying to. And also with the donors that create our material, if we could use those for treatment. So yeah, so those are the things. Identify better the microbes and the chemicals that are important to relieve some of the symptoms, and be able to use that to prevent success of treatment, and also to ideally at some point also grow some microbes in a bioreactor.
Yeah, I think that's it's amazing, just all the information and knowledge that you're adding to the field. But I think that it's wonderful that you're able to treat, whether that's therapeutics or interventions or treatments, from the knowledge, because that's how you make it accessible. That's how you put it out to the community. In order to do that, is that you mentioned, is that families have to be participants in this as you're going through trials and research. And the FDA, it's you need to have people who are going to be research participants. What could a family do if they want to be involved in this? Is that some of the most dedicated families out there are those with autistic individuals that are part of that family unit, and they're so willing to be oftentimes part of trial for knowledge and to pay forward. How can they do that with you?
Sure. So some of the amazing things of our trials, on our very first trial, we had 0 dropouts, which anyone who runs a clinical trial, you would know that that's amazing, because we have this amazing community. That's number one. And then also because we had so much success on the first trial, we always have a lot of applications to our trials. On our past trial, we had 50 spots, and within a week we had 1,000 applicants. I would still encourage people that are interested to apply, and the way that they can apply is my collaborator Jim keeps up a page for autism families, which is autism.asu.edu, and there's some information about our trials, information about our work, and there's also a way there to get on an email list, and that way they will be informed next time we have a trial, and then they can apply for the trial. The other thing is that if they're interested in the company and participating in the company, that's gut-brain axis therapeutics or gbat.com. GBAT is easier, gbat.com. And there's information there also about the company and about ways to, you can participate as a participant, but also financially, which is another thing that we need to run these trials. It's not cheap.
No, and quite frankly, is that the community, or the autism community in general, has been a driver in so much knowledge, and it goes beyond just the autism space. A lot of the information that's learned through some of these studies applies to so many different people. And I think that that's one of the things for me is that, I mean, we're right now in Autism Acceptance Month. And when I think about, there's a lot of commonalities. There's a lot of research and understanding that maybe affect autistic individuals more because it's something that maybe there's a bigger barrier caused by some of these challenges that are out there. But when I look at it, it's, when you start removing the barriers and kind of peeling back the layers, is that it's all about having folks with the ability to be included in everything, the ability to be able to be empowered, to be leaders, to kind of engage life in the way that they want to. The therapeutics and the science that you have invested your time and money and energy into, I think is a step forward anytime we're getting more knowledge. But what's the message that you'd like to share during Autism Acceptance Month, as we're celebrating so many families, so many neurodiverse individuals?
Well, so the first thing that I would say is, first of all, and most important, first of all, love them. Then about our research, I want to say that, we're interested in learning mechanisms from the data that we obtained so we can hopefully have better treatments and be able to help more people. Watch your diet, watch for constipation because constipation leads to bad microbes. But try to be supportive because we talked a lot about the gut-brain interaction, but there's also brain-gut interaction. So when you're stressed, you also affect your microbes, So a lot of the things that affect our microbiome affect ourselves too, which is stress, exercise, a few of the things that keep us healthy. Try to do that and try to do that include these children or adults with autism in all those activities with trying to be, more relaxed, exercise, eating better, all these things that make us, I guess, a more peaceful human being will help them too.
Yeah, things that benefit us all. I mean, it's funny how often I run into that where it's, the advice that we're giving and we're sharing for autistic families and individuals are things that when we do for ourselves, we also feel better. But Dr. Krajmalnik-Brown, thank you so much for coming on today and sharing your knowledge, your experience, and your time with us.
Thank you so much for inviting me. This was great.
Thank you for listening to Autism Weekly. We hope you tune back in next week to learn more about autism in the real world. Autism Weekly is now found on all the major listening apps, including Apple Podcasts, Stitcher, Spotify, Amazon Music, and more. Subscribe to be notified when we post a new podcast. Autism Weekly is produced by ABS Kids. ABS Kids is proud to provide diagnostic assessments and ABA therapy to children with developmental delays like autism spectrum disorder. You can learn more about ABS Kids and the Autism Weekly podcast by visiting abskids.com. Thanks for tuning in. See you again next week.